All right, I'm going to go over how we can solve these types of equations where you have like a binomial times a binomial equal to a binomial times another binomial. And we're going to look at like different variations of it, but it's in the main thing is to know that you don't have to always use like a complex or advanced formula. Usually you'll have to eventually use the quadratic formula um if you go when you go on to like algebra 2. But let's just take a look at these. So when you have like a binomial times a binomial, well, meaning that called binomial because you got two terms in each group, you want to make sure you distribute. So I'm going to distribute this x to this x, and then that x to that 7. So let's go up here and let's write x times x is x squared. X times 7 is 7x. Then I also need to distribute this -1 to that x and the -1 to the 7. So I have -1x minus 7, and I'm going to set that equal to, on the right side, I have this x times x, this x times -3. So I'm going to get equal to x squared minus 3x. And then likewise, I'm going to have 1 times x, 1 times -3. So I'll have plus 1x minus 3. Now I can just like start breaking this down, and let's first combine these like terms. So on the left, we'll have x squared, 7x minus 1x will make 6x minus 7 is equal to, carrying down the x squared, minus 3x plus 1x will be minus 2x minus 3. And then, sorry about that glare. This is a 7. Then we can like see more easily. You can cancel out that x squared. Just make it go away. Just, it's gone. And then we have left a 6x minus 7 is equal to negative 2x minus 3. Then what we can do is let's just add the 2x to each side. So we'll get 8x minus 7 equals negative 3. And then we'll just add this 7 to each side, and we'll get 8x equals 4. And dividing by 8, we'll get that x is 1/2. There you go. All right, the next one, let's look at yeah, I'm gonna erase that. Go away. Very next, same idea, similar. So let's go through it a little bit faster. X plus 4 times x plus 3. Let's go x times x times 3. We'll get x squared plus 3x. 4 times x, 4 times 3. So plus 4x plus 12 is equal to, let's go x times x times 1. So it's equal to x squared plus 1x. And then we'll go 2 times x, 2 times 1. So plus 2x plus 2. So right away, you can probably just get rid of these x squares if you can see that there's only one x squared on each side. Combining the 3x and 4x on the left, we get 7x plus 12 is equal to 1x plus 2x, so 3x plus 2. Should I go to the... Yeah, let me just work it down. Let's get rid of this 3x from each side. If we get rid of 3x from each side, we'll just get 4x plus 12 equals 2. Take away 12. from each side. And then we'll get 4x is equal to negative 10. Try to see that wrong. And then, so then we just divide by 4 for x, then we'll get x is 10 over, or negative 10 over 4, or negative 5 halves, negative 5 halves. All right, next we got, okay, this one we don't have the whole thing actually multiplied out, but we actually don't have a binomial times a binomial. What we have is 2x minus 5 times x minus 5 times 4. So on the left, I'm gonna erase that. I don't like saying, I like just reaching up and writing. Feels more powerful. All right, so 2x minus 5 times x, so minus 5x. Let's switch it up, minus with the red, minus 5x minus 5 times 4, so minus 20, is equal to, don't mess this part up. This is a common mistake. Negative 2 times x. So negative 2x. Negative 2 times 3. Minus 6. And just solve this. 2x minus 5x. Well, it's minus 3x. Minus 20. It's equal to negative 2x minus 6. I'm going to add 3x to this side so it's positive. So we'll have minus 20 equals 1x minus 6. Add 6 to the left. And we end up with negative 14 is equal to x. Yeah. And one more for now. Sorry, man, I gotta erase this. I know I have a lot more space, but I don't care. Okay, so x times x times 3, x squared plus 3x, 2 times x, 2 times 3, 2x plus 6 is equal to, what do you know? On the left, we already had it. X squared plus 5x plus 6. Hold on. Well, don't hold on. Let's combine these together. I don't really know what we mean by when we say hold on. Hold on to what? Okay, so x squared plus 5x. So you see, you got the same exact thing on both sides. Like you can subtract all that, and then students, for whatever reason, they're like, oh oh no, like I didn't know if it's it's all real numbers, or if it's infinitely many solutions, or if it's zero. Well, like if you take all this stuff away from the left, you're gonna get zero on the left. Take all this stuff away from the right, you get zero on the right. Zero is zero. This is a true equation. This essentially means that anything you plug in for x is gonna work. Because let's just say x is 1. Then I get 1 plus 5, 1 plus 5 plus 6, 1 plus 5 plus 6. That's true, of course, duh. Obviously. What if I make it x is 10? 100 plus 50 plus 6 is equal to 100 plus 50 plus 6. This is true as well. So this we say infinitely many solutions. or you can say all real numbers, and you may see this like symbol for all real numbers. It's going to look like this. Don't write some students in their elementary days, they'll write this the infinity symbol. This is not the same as saying infinitely many solutions. Like this is like this is kind of, it's not a number, but it's kind of to represent a number. We say we represent the behavior of a number, but this is like telling you how many solutions there are. The solution is not a very, very big number. The solutions, there's a lot of solutions is what we're saying. So don't just think that's not a big deal. If you're my student, don't think, oh, it's the same thing, Mr. Dela Cruz. You just don't like me. I'm just taking points off. Blah blah blah. No, it's because it actually is a difference. Like it's a big deal in math. Anyways, I hope that helps. Good luck, guys.